If you want to create your first deep learning application for classifying the contents of an image, you already have a dataset and would like to create a basic model and train it, in this quick tips episode, you will learn how. Keep watching. Hi there, I'm Manuel Gutierrez from thelighthouse.co, and I make videos that help you learn about different programming topics like AM, Docker, TensorFlow, Unity, and more. So if you're new here, hit the subscribe and the bell notification buttons below so you don't miss a thing. Let's start! This video is part of the ASL classification series where you'll implement a simple deep learning model using TensorFlow and Keras for classifying images. First, we define the problem that we want to solve, identifying hand signs for the American Sign Language ASL. Then, we collect or download some data representing examples of what we want to learn how to classify. Images of hands representing the ASL fingerspelling signs. We define and train a model that can capture, learn, and classify the visual data, this video. We evaluate the performance of the model to see how well it is classifying images. Finally, we use the trained model for predicting hand signs. Don't forget to join the free mini course in the description below. In this video for the Deep Learning ASL Classification series, I will define a multi-class classification model using Keras, then train it and check its progress. Let's create a function to define our classification model. It will receive the input shape for the images given the width, height, and channels or colors, and output shape for the number of labels or possible classes. We have, in this case, numbers from 0 to 9 and most of the letters of the alphabet. Start by defining a sequential model that will cause inputs, in this case images, to go from one layer to the next one. Given that we are working with 2D images, I am going to use convolutional neural networks to process them. To keep it simple, for the first block, I will add a conv2D layer and pass the shape of the images given that this is the first layer. Another conv2D with similar configurations to analyze the images, and a max pooling 2D layer to downsample the outputs of the previous layer. Then, typically, you would stack a couple more blocks with similar configurations, but, for example, doubling the number of filters in each subsequent block. We use flatten to transform our matrix into a vector of values so that we can fit it into a fully connected or dense layer. We have the output layer for which we set the number of units to be equal to the number of possible classes or hand signs that we want to classify. And given that we have more than 2 classes, we set softmax as the activation for this layer. Finally, compile the model using Adam as the optimizer, which will use the loss function to check how far the model is from the correct answers and make corrective adjustments to get as near as possible to some acceptable performance. Also, we set accuracy as the metric so that we can judge if the model is improving. You can see the resulting model below. Transform the image arrays and start the training process by passing the set of images for training and corresponding correct labels, a batch size, the number of times to go through all the images or epochs, and a tuple with the set of images for validation and their labels. At the end, store the results of the training process in the history variable. Store its history attribute in another variable, and print the final training and validation accuracy. You might get slightly different values for the loss or the validation, but it is expected. So, what happens here when we start the training process is that the model takes the set of images that we defined for training and moves them through each layer of the model to be processed, until it gets to the output layer, which will return the label or class/category that the model thinks belongs to the image. Then the optimizer evaluates how correct or wrong the predictions are and makes adjustments to the model so that next time images go through the same process, the results start to improve. In the next video, I'll take the model we've just trained, plot its performance, and talk a bit about the results. Awesome! Congratulations and thanks for watching! You can join the free mini course associated with this video by clicking on the link in the description below. Share any comments or suggestions about the series or future topics. And if you like the video, also hit the like button below.